1474 delete n nodes after m nodes of a linked list. So the problem is very straightforward, just like the title. So we're gonna delete n nodes after m nodes. So in this example, we have such kind of a linked list. So we're gonna delete n nodes. N gonna be 3 after m nodes. So this is 1. This is yeah. Let me just try another color. So this is 1. This is 2. So after 2 nodes, we're gonna delete those 3 nodes. And after those 2 nodes, we're gonna delete those 3 nodes. And after 2 nodes, we're gonna delete those 3 nodes. But currently we don't have 3 nodes. But so we need to just delete 1 node. So that is okay. So finally, we're gonna have like 1, 2, 6, 7, 11, and 12. Yeah. Let's just check another example. So here in the second example, we're gonna delete 3 nodes after 1 node. So after this node, we're gonna delete those 3 nodes. After this node 5, we're gonna delete those 3 nodes. After this node, we're gonna delete those 2 nodes because we don't have 3 nodes. So finally, we're gonna have 1, 5, and 9. Yeah. So we can put all the nodes inside an array, and we're gonna use the array to solve the problem. That is okay. But there's gonna be a follow-up. Could you solve it by using O1 space? So this means we're gonna solve it in place. Basically, we're gonna just loop through the linked list instead of an array. But how can we do that? Normally for the linked list problem, we're gonna prepare let me say we're gonna prepare a dummy pointer. It's gonna be an empty list node from the beginning. Yeah. So we're gonna prepare a pointer p gonna equal to dummy, gonna equal to the list node, and p.next gonna equal to the head. So this is the preparation, because definitely we're gonna delete something. If we prepare a dummy node, it's gonna be really easy for us to have the final return, because the final return is gonna be the dummy dot next. Yeah. As we are going to count this m and n, so we're gonna prepare a counter. So it's gonna be count m and count n. So it's gonna be 0 and 0 from the beginning. Now we're gonna just loop through the linked list. So while p dot next, yeah. So p gonna equal to p dot next, and the counter of m gonna plus equal to 1. Now we're gonna check this counter m. If it is equal to m, so yeah, let me just use the first example. Yeah. So in the first example, from the beginning, we have p pointer. It is pointed to the dummy node. So this is a dummy node, and this is a p pointer, and it is pointed to the head. Yeah. Now from the beginning, my p pointer is here. So I'm gonna check the next. So p dot next exists. So yeah, the counter gonna plus 1. So the counter of m gonna become 1, and then my p pointer gonna pointed to this node 1. Yeah. And as it has a next, so it's gonna be pointed to 2 at the same time. So the counter gonna become 2. Yeah. So if this counter equal to m, yeah. So here, if this counter equal to m, I'm gonna reset the counter of m. I'm gonna start next loop to delete n nodes. Yeah. If it is equal, I'm gonna set the counter m gonna equal to 0. And I'm gonna use another while loop to delete n nodes after that. Yeah. So for deleting a node of the linked list, it's gonna be p.next gonna equal to p.next.next. So this is gonna be the deleting operation. So the counter n gonna be updated to 1. Now we're gonna check this counter n. If this equal to n, definitely we're gonna break it. Yeah, because we don't want to delete it all the time. If it is equal to n, definitely we don't need to delete. So we're gonna stop the while loop, and we're gonna execute the outer while loop to continue the coding. And after coding too, we're gonna continue the deleting. But before the break, we need to set the counter n to 0 as well. So here is similar like the counter m. Yeah, because for the next one, we still need to count it from 0 to n instead of n to other numbers. Yeah. Now let me just run it. Now as you can see, it works. Now let me just submit it to check. As you can see, it works, and it's pretty fast, and the time complexity is O(n), and the space complexity is O1, and this n gonna be the number of nodes. It's gonna be 10 to the power of 4. Thank you for watching. See you next time.